K nearest neighbors classification, and our team members are Sophia, Chaitra, Trupti. Uh, Today I'm going to give introduction about K nearest neighbors. The K nearest neighbor algorithm is a simple yet powerful supervised machine learning technique used for both classification and regression tasks. It classifies a data point based on the majority class among its k nearest neighbors in the future space. This project aim is to implement and evaluate a KNN model in the dataset, a well-known real-world dataset, and analyze performance by experimenting with different k values. Performance will be measured using metrics such as accuracy, precision, recall, and confusion matrix. The next part is continued by Sophia.
Good morning, my name is Sufia and my topic is objectives. So the objective here is to build and evaluate a KNN classifier for a real world data set. That is here we are taking the iris data set and experimenting with different values of K to identify the optimal number of neighbors that gives the highest accuracy. So this is our objective. Next I'm going to explain the methodology of this. So here the first step is for the data set selection. So data set used here is iris data set. That is we have taken this from scikit-learn library. So then the description of this is the dataset contains 150 samples. Here, the dataset we have taken here it contains 150 samples of iris flowers. So each described from four features. So the first is sepal length, sepal width, petal length, and petal width. Then we have the classes. In classes, it is the target labels. So that is Iris setosa, Iris versicolor, Iris virginica. Then in the step 2, we are data pre-processing. We are doing the data pre-processing, which is splitting the data set into training and testing. That is 70% for training and 30% for testing. Then here standardizing the features using the standard scaler to normalize the numeric values. So here we'll be standardizing the features here. In step 3, we have the model implementation, which is implemented K-neighbor classifier from scikit-learn. So the train the model using multiple values of k, like from 1 to 15, to determine the optimal number of neighbors. Yeah, next will be continued by Chaitra.
I will go through the code explanation. So we are importing the libraries as pandas. Pandas we import for handling and analyzing data in table format. And the next line import numpy as np. Numpy we use for numerical operations and seaborn is used for visualization the data. Matplot matplotlib is used for the plotting the libraries. And the next from sklearn dataset import load iris. So from this line we load the dataset from sklearn. From sklearn model select import train test data split train test data split which splits the data into training and testing sets. From sklearn pre-processing import standard scalar. The standardized feature makes them have mean 0 or standard deviation as 1. From sklearn neighbor, import KN neighbor classifier. So machine learning model for classification. From sklearn matrix, import accuracy score, confusion matrix, and classification. This is used for the confusion matrix to evaluate the model performance. Data load Data load iris, it loads the data and stores in the variable called data. Data includes features, values like sepal, petal, length, and width. Data target. Data target, it includes the labels like flower species and it defines the et feature. As previously we had already imported the library as Panda from sklearn dataset, we import the load Irish flower. So this function is used to provide the Irish flower dataset. Data is equals to load Irish. This line loads the dataset and store it in the variable data. It is a dictionary like object that contains data data dot target and data dot features, where data dot data it is the measurement, and data dot feature names the columns and the name. Data target labels the types of the flowers, and data target names the actual species name. The output will be in this form, where it displays the first 5 rows of the data frame to check the data. You will see the tables like this as sepal length, sepal width, petal width, and target. It loads it loads the data set, converts it into a readable format data using pandas, adds the target like flowers categories, displays the first few rows on understanding. The main goal of this code is to split the data set into training and testing sets. So it scales the feature values from better model and accuracy. So let us go through the step-by-step explanation. From sklearn pre-processing import standardize. This imports the train test split functions from sklearn selection. It is used to divide the dataset into two parts, where training set and testing set. Training test is used to train the model, and testing set used to check how well the model performs on unseen data set. Now let's split the target. Here the data is split into the targets. So x is defined as df I loc and colon minus 1, where y is df target. So x all the columns expects the last one. The input features like sepal, petal length, and width, where Y represents the target column, that is the flower species. So, X is the measurement, which is input, and Y is the sepal label, which is output. It splits the data into training and testing, where X train and X test, Y train and Y test is equals to train test split. So in this, 30% of data goes into testing and 70% for training. Random state they have given as 42. So it ensures and it ensures a split is the same every time, even when you run the code for repetitively. The output will be in such a form where x train, x test, y train, and y test, where x train is the input features of training and x test is the input features for testing. So y train is the corresponding training labels, and y test is the corresponding testing labels. So let us go through this code more carefully, line by line, and so we'll understand it what's happening in this code. The purpose of this code is the part of program that in this part it happens the data preparing before applying the KNN model, where it splits the data into training and testing as I told before, scales the features so that all measurements on the same scale. So as here it imports matplotlib library to plot the graph. From sklearn, Neighbours imports k-near label classifier, where it imports the KNN classification model from sklearn machine learning library. The next line from sklearn.matrix imports accuracy score. It imports the accuracy score functions from sklearn to evaluate how well the model performs. And the accuracy score, it initialize an empty list named accuracy score. This list will store the performance of the KNN model for each k value tested. And for loop, this for loop iterates through k values from 1 to 15 trains to model for each and calculate the accuracy. For k in range 1 comma 16, it starts the loop from iterating k from 1 up to 16. So k will take values like 1 comma 2 comma 3 up to 16. The next line, KNN is equals to K neighbor classification classifier n neighbors is equal to K. It creates a new KNN model objects settings the number of neighbors to calculate the values of K in the loop. The next line, KNN.fit. This line trains the KNN model using the feature data and tests the corresponding labels from the training set. Y predict KNN.predict X test. So it makes the prediction on the separate test feature and stores the result in Y predict. Then ACC is equals to accuracy score Y test Y predict. This line calculates the classification by accuracy by comparing the true test labels with the models and prediction. And the next accuracy score dot append. This line adds and calculates the accuracy to the to accuracy score of list. PLT refers to plotting. So this section creates the visualization that helps identify the best k value. The first line in this it figures that creates a new figure setting its size of 8 inches and width of 5-inch tall. Next line, plt.plot that has range of 1 comma 16 that generates a range of 1 to 16 where y is the accuracy value. Then accuracy score, it represents each point is marked with a circle. And next the marker is equals to 0 and the line is in a blue color and color is equals to b that represents the blue color. Then plot.x title, this line accuracy versus k value. It sets the title of the plot. Then plot.x label, it labels the x axis to indicate the number of neighbors tested. Plot.y label, this y axis the indicates the models as where the graph represents both x axis and y axis. This two line indicates that the graph plotted from x to y axis. Next, plot is equals to y label accuracy. So it labels the y axis. In y axis, it labels and indicates the model accuracy. And plot.grid true, it adds a grid to the plot for the easier reading of values. Plot.show, it displays the final plot on the screen. This is how the output looks finally, and where I previously mentioned we have both x axis and y axis where x axis represents accuracy and y axis represents accuracy and x axis represents number of neighbors. And as I told, the line will be plotted in blue and this is how the output is shown. So finally, we have come to the final code for finding the best k value, where best k is equals to np dot arg max accuracy score plus 1. This indicates that calculates the optimal k value, where np rmg max accuracy score, it returns the index position in the accuracy scores list where the highest accuracy score was found. Since Python files are O index, 0 index, and the k value started at 1, added to the index to get the actual k value. The next line, print for f best. It prints and determines the optimal k value to console. Example, best k value, where we'll take a best k value as 3. Next, finding the training and test prediction. In this line, we'll be predicting the values where KNN is equals to K neighbor classification. So it creates the final KNN model instance setting the number of neighbors. KNN fit X train Y train. So in this, it trains the final optimal model using training data, X train and Y train. In the next line, Y predict is equals to KNN dot predict X test. It makes the prediction on the test features where X test using the optimally trained model. Next will be printing the values where it reporting model performance, which this line reports the modeling performance. Where print accuracy, it prints the final accuracy score comparing the true test. It compares the true test and prints the accuracy score, which is Y test. It prints in the Y test, and with the model predict, it predicts from Y prediction. Then predicts the N classification report. Prints the detailed classification. In this line, it prints the detailed classification report. This reports provide essential metrics like precision, recall, and F1 score. Confusion matrix consists of the prediction, precision, recall, and F1 score for each class in the dataset. What this does, it offers the more completely view and performs the it then performs the accuracy. So, finally, confusion matrix. In the last, this particular paragraph tells us about the confusion matrix, where confusion matrix is a table that is often used to describe the performance of a classification model on a set of test data which is true values are known. Only if the true values is known, we will find the confusion matrix. So now, the CM is equals to, let us consider CM is equals to confusion matrix, Y test and Y predict. So what does this line do? It predicts the confusion matrix by comparing the true test labels from Y test and against the prediction of Y prediction. So SNS heat map this line generates the heat map visualization of confusion matrix using a library called Seaborn. SNS is represented as Seaborn library. In this line, it can be true when it adds the numerical value to the cells. So FMT is equals to D. It formats the number as a integers. So C map is equals to blue, where the map is represented in C schemas. Next, then plot dot title, that is confusion matrix. It sets the title for the heat map plot. Plot dot x label prediction label. This label in x axis are predicted labels, which is already predicted. This label, this line shows us it, which is already predicted. Then plot dot y label true label. In the bracket of true labels, labels are from y-axis as are true as true labels. The labels from y-axis are true. Then plt dot y label plt dot show, it displays and generates the heat map visualization. So the best, let's consider a best of three that indicates k results in the highest accuracy during the initial test. During the initial test, and accuracy is 1.0. It indicates the final model correctly predicted 100% of test data. Usually the high and mild suggestion issues like data leakage of or very easy data set. So the output image displays the or generates the previous code, which is trained and evaluated using a k nearest neighbor model that consists two main parts: the classification report and a confusion matrix. So let's just go from a classification report, where classification report provides us a detailed pre-class evaluation of model performance. So the first we have a rows with precision, recall, F1 score, and support. So we have classes from 0, 1, 2, and 3. These are the different categories model for training classification, where precision is the ratio of correctly predicted position, observation of the model trained and predicted, and recall is a ratio of correctly predicted positive observation to all observation in the actual classes, and F1 score is a harmonic mean of precision and recall, a good indicator of models. Then support, it is actual number of occurrence of each classes in the test data. Accuracy, it is the overall accuracy from 1 or 100%. So this is overall about classification. And confusion matrix table has a row and column, rows and columns, where rows represents the true labels and columns represents the predicted labels. So true 0 is 19. Here true 0 is 19, and true 1 prediction is 13, and one more is true 2 prediction is not explicitly labeled, but implementally it is on 13. All other diagonal cells are 0. Only the three labels where we wanted 0, 1 and 2. 0 is of 19 and 1 is of 13, and 13 is not completely explicitly explained, but it is implementally 13. So this is overall the code explanation, and the next part is followed by Trupti.
Now I am explaining tools and libraries. Python tool, it is used for primary programming language. And next sklearn, it is used for KNN model, training and testing split and evaluation method. And pandas, it is used for data manipulation and data handling. NumPy, it is used for numerical computation. Matplotlib, it is used for visualization of accuracy and matrices. Seaborn, enhanced visualization, example like heat maps and charts. Next, conclusion. The KNN classifier achieved 99% accuracy uh, on this iris dataset. The optimal K value was formed to be 5. Visualization of result confirmed model reliability. Future improvements could include testing on larger or nicer dataset and comparing KNN with other algorithms like SVM or decision tree. Thank you.
From behalf of all of us, I thank ma'am for giving us this opportunity for doing this video from online. We had a great experience, and we learned more about the topic and the code explanation. We learned deeper about the code, and we had a great time. Thank you, ma'am.